All right, welcome. Today, we're going to really level up your C programming skills. We're moving past the simple stuff, the basic variables, and diving into how to handle complex, real-world data and do it in a way that's super efficient and, honestly, pretty cool.
Okay, so here's the game plan. We're going to start with the absolute basics, the building block of it all. Then, we'll see how to scale that up to handle tons of records. After that, we'll get into making our code clean with functions, and then we'll add some layers of complexity. And finally, we'll put it all together to see how you can build some seriously powerful data models. Let's do it.
So let's kick things off with a problem I'm sure you've thought about. You've got to manage data for, say, 500 students. How do you actually do that? I mean, you need their ID, their name, their GPA, for every single one. You're not going to create 500 sets of variables, right? That's 1,500 separate variables. It would be an absolute nightmare to manage. This exact problem, this is why we're here today.
So, to tackle that huge, messy data problem, you need the right tool for the job. And in C, that tool is the struct. We've got to start here with this fundamental building block because, trust me, everything else we talk about today is built right on top of this idea.
So what is a struct? Well, the best way to think about it is like a blueprint, or a template you design yourself. See, you're not just stuck with a plain old int or a char. You get to create your own custom data type. A little container that holds exactly the mix of information you need. It's kind of like designing a custom index card just for a student's info.
And here we go. This is exactly what that looks like in code. We've defined a struct and called it student. And look what's inside. An integer for the ID, an array of characters for the name, and a float for the GPA. It's all bundled together in one neat logical package. That custom index card we just talked about, this is it. We've just brought it to life.
Okay, so that student struct is awesome for one student. But what about our original problem? We've got 500 of them. So the big question is, how do we scale this up? How do we go from one tidy record to managing hundreds?
And the answer is an array of structures. This is the key. So if a single struct is our custom index card, then an array of them is the whole filing cabinet. It's just a whole collection of those cards, all the same type, all neatly organized and stored together.
And would you look at that? One single line of code. Struct student classroom 500. Bam, problem solved. With just this one line, we've declared an array called classroom that can hold 500 of our student structures. We've literally just built our digital filing cabinet.
And the beauty of this is how crazy organized it is. If you want to get the first student's entire record, boom, classroom 0. The second, classroom 1. It's that easy. And if you need a specific piece of info, like the GPA of that first student, you just chain it together with a dot, classroom0.gpa. It's super direct, super clean.
All right, so we've got our data all sorted out. It's sitting there, perfectly organized in our digital filing cabinet. But data just sitting there isn't all that useful, right? We need to do stuff with it. And to avoid writing the same messy code over and over again, well, that's where functions come in.
Honestly, this is a total game changer for keeping your code from becoming a tangled mess. Instead of jamming everything into your main program, you can create these little specialized, reusable tools, these functions, that just do one job and do it well. Think about it. You could write one function whose only job is to take a student struct and print its details out perfectly, every single time.
Now, when you do this, you've got a big decision to make. How do you actually give the data to the function? The first way, pass by value, makes a complete copy of the student record. This is safe, right? The function can't mess with your original data. But if your struct is big, making all those copies can be slow. The other way, pass by reference, just sends the memory address, like a little note saying, the data's over here. It's way faster and more efficient. But you gotta be careful, because now the function can change the original data. It's that classic programming trade-off, safety versus performance. So our student model is getting pretty good, but let's be real. The real world is messy. It's complex. A student has an ID and a name, sure, but what about their birthday? A date of birth isn't just one number. It has parts, right? A day, a month, a year. We need a way to model this kind of layered data.
And this is where nested structures come into play. And the idea is actually super simple. You just put one structure inside another one. It's exactly like those Russian nesting dolls. You've got the big doll on the outside, that's our student, and when you open it up, you find a smaller, more specific doll inside, our date of birth.
So how do you build this? Well, it's pretty logical. You start from the inside out. First, you define that inner doll.
In this case, we create a simple date of birth struct that just holds an integer for the day, the month, and the year. Okay, once you have that, you just pop it right inside your main student structure. Take a look. We've declared a member called DOB, and its type is struct date of birth. It's treated just like any other piece of the student struct, right alongside the ID and the name. So the question is, how do you get to that data that's buried inside? It's actually just the logical path. You start with your main variable, say new student, then you use a dot to go inside to the DOB member, and from there you use another dot to get to the year. See? newstudent.dob.year. It's like following a breadcrumb trail right to the piece of data you need.
All right, so we've looked at all these different pieces, right? Structures, arrays, functions, and nesting. But the real magic happens when you stop thinking about them as separate things and start combining them. Let's see how they all come together.
So let's just recap what we've put in our C programming toolkit today. We've got arrays of structures so you can handle huge amounts of data. We've got passing structures to functions so you can write clean, modular code that's easy to reuse. And we've got nested structures so you can accurately model complex, real-world data. The best part? You can mix and match all of these. The possibilities are huge.
And this, right here, is why all of this really matters. You're not just dealing with loose numbers and characters anymore. You've got the tools to actually design and build sophisticated data systems. You could model a car with a nested structure for its engine parts, or a whole library with books and their authors. You can build entire data worlds in your code. So the real question is, what are you going to build?